Alright, so just another one of these distance and time graphs with multiple stages in the journey examples. Okay, so I have a journey here which is distance in kilometers and time in hours. So you're looking at these before, but before it was just a single straight line. So there was just one constant steady speed for the journey. You got the speed by getting the slope of the line using any 2 points along it, or maybe you got the total distance and put it over total time using the speed distance and time formula. These ones are a little bit different because it's not just a single straight line. Okay, you've got kind of line going upwards, horizontal line going upwards, horizontal line going downwards, and they all have slightly different meanings. They all mean different stages in the journey. Okay, it's all down here in these points towards the bottom, but I'll talk through it here. So from point A to point B, that person goes from 0 kilometers to B is 20 kilometers. So they've traveled 20 kilometers, and on the x-axis they've gone from 0 hours to 1 hour. Okay, so that's A to B. All right, and we're told down the bottom there that that's them cycling. If they've traveled 20 kilometers in 1 hour, they've gone 20 kilometers per hour. That should be straightforward enough. Okay, you could get that using the distance and time formula. So distance 20 over time 1, 20 divided by 1 is 1. You could pick 2 points. So you could pick this point here and this point here, pick A and B, and the rise between those is 20. Okay, so remember, don't forget to take the rise in the units the question is in. So it's not going up in ones, it's going up in tens for every box here. So rise of 20 and a run then of 1 hour. So 20 over 1 is 20 kilometers per hour. Okay, so just be careful. Okay, if you're looking for the speed in this part of the journey, both your points need to be in that part of the journey. So you could take that point there and this point here. That will be fine as well. But what you can't do is say, take this point and this point, because there's no line between those. There's no line you're getting the slope of. All right, no straight line, I mean. So that's 20 kilometers an hour, the first part. Then between B and C, the line goes flat, or it's horizontal. Now, the y-axis is distance. So as long as we're traveling up or down, we're covering some distance. A flat part of a line like this means we're stopped. Okay, so at B, he stopped for half. This is just him stopping for a rest, maybe. All right, so this horizontal line here means he's stopped. How long has he stopped for? Well, every 4 boxes is 1 hour on the x-axis. So between B and C is 2 boxes out of 4. So 2 out of 4 is a half. So that's half an hour or 30 minutes. Okay, so he stopped for 30 minutes. Then between C and D, he gets going again. Now, we can tell between C and D, he is traveling faster than between A and B. How can we tell? The line is steeper. So the steeper these lines, the faster you are traveling. Okay, so if I wanted to get the exact speed then, so from point C to point D, you are going from 20 kilometers to 60 kilometers. Okay, so if you were doing the speed equals distance over time formula, that would be distance 40 over, what's the time? So the time between C and D is 1.5 hours to 2 hours. Okay, so it's half an hour. Now, I generally don't want speed in kilometers per minute. I want it in kilometers per hour. Okay, so I'm going to divide 40 by a half an hour. So a half is 0.5. Okay, or you can do 1 over 2 on your calculator as well. If you do 40 divided by 1 over 2 or 40 divided by a half, you'll get 80 kilometers per hour as your answer. Okay. so 80 kilometers per hour, not writing the units in here, is the speed between C and D. You could also have got that using the slope. So pick, say, the same 2 points, and the rise is 40, and the run, just be careful, the run here has to be given in the units there, so it'll be 40 over a half as well. So between here and here is a half, okay? You could also pick maybe this point and this point, okay? The rise between those will be 20, and the run between those 2 points would be just 1 box, which is a quarter. So you'd be doing 20 divided by a quarter, which would also give you 80 kilometers per hour as your speed. Okay, so between C and D there, I could see straight away that I was traveling faster because the line was clearly steeper than it was between A and B. But to figure out the exact speed, and if you're asked in what part is he traveling fastest, don't just say, well, you could, I think you could say it's clearly steeper, but I think better off figuring out the actual speeds as well. If a question ever asked you, what section of the journey is he traveling fastest in? Okay, so you can, if you want, compare the slopes, but if they say, how do you know from the graph, say yes, because I'm comparing the slopes, but I would also actually figure out the speed, the actual number. At D, then he takes a rest again, so the line is horizontal, so he's staying at 60 kilometers from where he started or from home. So there's a rest, and that is a half an hour again, so it's 2 boxes. 2 boxes is 2 out of 4, half an hour. And then during the last part of the journey, so from E to F, okay? So the line is going downwards here. So as long as it's going up or down, you're covering distance, you're traveling. Just to say, the fact that he's going down, if you get the slope here, you're going to get a negative slope. That doesn't really make sense because it's speed, okay? So this is distance from home, okay? So all going downwards means is you're traveling back towards home, okay? So just if you do get any negative answers here for speed when we do it, change them to a positive. Speed is always going to be positive, okay? So from E to F there, I would say he's going faster again, okay? It's downwards, so maybe it's slightly hard to compare it to DC, but it looks steeper, okay, than CD. So I would imagine this bit's going to be the fastest that he's traveled. All right, how could I do it? We'll get the slope. So say I'll pick 2 points, which are going to just say this one and this one. Okay, so what's the rise between those 2 points? Well, it's 1, 2, 3 boxes. So that'd be 30 kilometers. So every 1 box is 30. Every 1 box is 10 kilometers on this. So the rise is 30. And the run then, okay, so it's 1 box here. 4 boxes is an hour. So it's 1/4 of an hour, or 15 over 60. How are you going to do it? But it needs to be decimal hours that goes in here. So 1/4 of an hour is 0.25. If you do 30 divided by 0.25, you are going to get 120 kilometers per hour as your speed. Okay, and like I said, normally on one of these we'd call that minus 30, but just in these questions here where it's distance, we won't. Okay, or you could call it minus 30 here and just change your answer to a positive at the end because speed has to be positive. Okay. We could have also got the speed there just by getting what's the total distance traveled by the total time. So from E to F, the total distance traveled, you're going from 60 kilometers away from where you started to 0 kilometers back where you started. So that's a distance of 60. And what's the time taken? So from here to here, 2 boxes out of 4. 4 boxes being an hour, so 2 out of 4 is a half. So 0.5, and 60 divided by 0.5 would be 120. So it shouldn't matter how you cover or how you calculate the speed. If you use the formula, if you use the slope, if you just kind of go 60 kilometers in half an hour, 2 half-hours in an hour, 2 60s or 120. If you kind of do it informally like that, you should still get the same answer. Okay, so as I said, steeper, so you're going faster between E and F, 120 kilometers per hour. Okay, so A and F, you'll see down the bottom here. Note that both A and F represent some town. Okay, so you're back where you started when you're on point F. Okay, you're back. All right, so that's how you do these multi-part journeys. So it's just like a few of those questions on Thursday or Friday last week, kind of put together onto one graph. So just be careful, look at the individual bits of the graph together. Okay, so look at A to B, look at B to C, look at C to D, look at D to E, look at E to F, and you'll calculate speeds, etc. for them separately. All right.